So I've been saying for like a couple years now, well basically since I got this tractor, I'm going to put some kind of power steering on it. Well, I've been putting it off and putting it off, and I put it off too long. I drove it here and the steering gave out because I've been overusing the steering wheel because of all this extra weight on the front, and it's still manual steering. Anyway, we got to fix that because it's in the middle of my yard and I can't move it basically. So let's do the long-awaited power steering project for Svetlana tractor. So I really want power steering. I said this from the start, and I don't know, I got to work something out. But the first step is to figure out what the range of our steering is, like full lock to lock on these wheels, because whatever hydraulic cylinder I pick or find, that's going to be the minimum cylinder run in and run out that we need. So I got to measure that. I think I can just get the front end up with the loader and then crank the wheel back and forth and measure it. So yeah, let's see if we can do that. So it's 7.5 inches center to center, 8 inches if I round up. So we need a hydraulic cylinder with an 8-inch throw front to back. I don't know if that's what you call it. 8-inch cycle, 8-inch, I don't know, whatever. So that's what we got to find. So I have decided to go with not a hydraulic system, but rather a electric linear actuator. Linear actuators have a lot of disadvantages, but they also have a lot of advantages. Advantage, I don't have to plumb into the hydraulic system again. I'm already running the loader, and there's a lot of hydraulics, and hydraulics are expensive. Linear actuators, you only have the cost of the actuator itself, basically, and I have all the other wiring gear and everything required, so that's not a problem. Disadvantages with the electric linear actuator is primarily speed. Secondary is power, but we're just moving the wheels back and forth, and if power is an issue, I can modify it. I can get a stronger linear actuator, that's fine, and even if I have to do that, I'll still be under the cost of what it would be for a hydraulic system. The speed, I have found the fastest one I could, and since the throw in either direction is less than 4 inches, when you're turning the wheel and you're expecting to make that turn, the linear actuator only has to travel in 4 inches to go from straight ahead to one way or the other. So we are going to do that. It's ill-advised. I have no idea if it's going to work. I've looked online to see if anybody else has ever done this, and good or bad, and I haven't even found anybody who's done it and failed at it, or at least anybody who's admitted it. So there's a couple options I just briefly touched on there. You know, we go hydraulic, but I don't want to go hydraulic because I explained that. A couple viewers, when I mentioned doing power steering on this, either sent me links or mentioned doing themselves an electric power steering, like from a car, and splitting the column and mounting it in place on the column. That is a great option, and I applaud anyone who has the time and energy to do that. It's more ideal because when you turn it, it's an electric assist. You can still turn the wheel manually, and you know, even if the electric power steering is dead, you can still it's a direct connection on the shaft, and you can still turn the wheel. I really like that option. It's a great idea, and the problem is I knew my column was shot. I knew I was probably going to have to end up going to the other column I have from an older tractor, which has it has a box cast in the top of the column, cast or welded, I'm not sure, but there's electrical stuff that bolts to it, and there's an access cover, and basically it's really inconvenient for putting the power steering in. So I would have to probably mix and match parts from columns that I have, and it wouldn't work. And you know, because I don't even think the parts are, you can mix, I don't think you can mix them up. And I don't want to buy a new column, and it just would have snowballed, for one thing. The second reason I don't want to do that is because if it ever breaks or anything, you're kind of up the creek on your own, because a lot of these electric boxes are kind of bespoke for their different cars, and if you can't find a replacement, sometimes they're expensive. You know, sometimes they're cheap if you can get a one-off from a junkyard or something, but if anything ever happens to it, you're going to have to fix it or repair it or rebuild it on your own. And I'm trying to keep this simple. The whole concept of this tractor is simplicity and ease of repair, and I would like to maintain as much of that as possible. I don't want to add excess difficulty of repair down the road if anything ever happens. You know, I want to keep it easy to repair with kind of universal type parts that are easy to get. So that's the two reasons mainly that I don't want to go with the electric power steering mounted on the column, even though it's a great idea and I love the idea of it. It's not right for this situation right now. So I'm going to be brutally honest here. The main reason that I want to do a steering system with a linear actuator is because I can't find anybody else that's done it. And I just want to do an experiment, basically, and see what happens when you do it. Yes, I'm probably doing this the wrong way, but I'm kind of, you know, science and all that. But in the end, I want to do it because I can't find any data on it. And I just feel like I'm here, I have the situation to do it. So, you know, let's do that. So that's really the main, I can justify it with a whole bunch of other reasons, but that's really the main reason that I want to do a linear actuator, let's face it. I don't know, we're going to try it and see, basically, is what I'm saying. So let me just show you kind of what I'm thinking as far as how this is going to be set up. So let me describe my thinking on the geometry of this steering setup. So we're going to cut this rod, so it's going to be separated in half at, I'm not sure exactly where yet. And this half is going to be connected to the linear actuator, and this half is going to be connected to the switch section of the circuit, so that when you move the steering wheel back and forth, it'll activate the forward or back switch and push this forward or back. That's the basics of it. I think I'm going to mount the linear actuator. Originally I was going to mount it between the engine and the rod, but there's not a lot of room there, and I don't want to block access to things like the injection pump and the oil dipstick. So I think ideally I'm going to mount it underneath. Since I have this nice big area of space here, I can use any of those bolts there to make a bracket to mount the linear actuator, because it has to push against something solid on the tractor that isn't movable. If you just put a linear actuator in the rod, it's just going to push back in the steering wheel right at you, so that's not going to work. It has to be mounted on something that's not going to move. So we'll fab a bracket up that will mount the linear actuator on the one end, and then the other end will be connected to this rod. I think that will work for the basics of the system. Alright, I apologize for the messiness of this part of the video, but I have to film this on my computer screen because, well, you know, technology limitations. So this is my rough model of how the steering is going to look. This red part over here is the tractor bell housing, and this blue part is going to be the linear actuator, and the purple part is the existing steering rod that I'm going to section and take out a couple inches of. And then I'm going to add in this bar here that is going to roughly connect the two. It's going to be pinned at this end on the steering end, and it's going to be in a sliding slot here, so it can go back and forth just a little bit so it can reach the linear actuator switches here. So these micro switches, which are, here's the real switch here, they're pretty tiny. I thought they were going to be bigger, but actually this might work out a little better because there will be less distance before you have to turn the wheel before it actually triggers the linear actuator on the steering. So there'll be a little less what you would call solid slop, you know, where you have to steer manually before you reach the assist part. So the micro switches are going to ride on this arced piece of metal here, and when this piece slides this way or this way, it's going to activate either the forward or back linear actuator. And the way those work is, if you don't know, this presses down and activates the switch. These have a normally open and normally closed, so you can wire these either way, but when it's going to slide back and it's going to activate the switch, or it's going to slide forward and activate the switch. So as this is connected, this is going to be welded to the steering rod. So as this rod slides back and forth when you turn the wheel, this will also turn back and forth and activate the micro switches just a little bit. Now, of course, there's going to be a limit of this slot here, because when it reaches, I've calculated it at about 3/4 of an inch. So when this rod slides forward 3/4 of an inch, it'll hit the solid stop back here, or up here if you go the other way, and that'll hold the micro switch on the low point. So you'll have continuous assist if you hold it against the stop. And then, of course, as the cylinder extends or retracts, depending on your position, it'll back it off the stop and then deactivate the circuit, because the micro switch will go back to the raised position again. So I know this might seem confusing. It's a little hard to explain without an actual demonstration model, but this is roughly how I'm going to do it. So I'm going to bolt the bracket for the linear actuator to the bell housing here, and then I'm going to bolt the other end of the linear actuator to the steering rod, and along with this bar that's going to connect the two. So that is roughly how it's going to look. The linear actuator is going to be mounted underneath the steering bar, and it'll push or retract against the steering rods. So here's the linear actuator we're going to be using. So we need to find the center point of this, because when we install it, we're going to install it with the wheels straight and at the middle point, so it needs to be able to come back or forward a half run. So I can manually operate this without any micro switches, so I'm going to retract it all the way. I'm going to mark the point there where it's fully retracted, and then I'm going to extend it all the way, and then I'm going to mark that point, and then I'm going to find the middle point. I can find, oh, that's exactly 8 inches. They're not lying. So now I can mark it at 4 inches. So that's my center point. So when I'm actually installing it with the wheels straight, that's where the unit should be retracted to. So right there. So that's the point that we're actually going to install it. So we need to fab up some brackets. And basically I'm just going to try to minimize that. My plasma cutter is not set up, so I'm going to cut out all these brackets by hand, unfortunately. But on the upside, this is something that anybody could do with an angle grinder and a drill, so get ready to watch me suffer, is what I'm saying. So that said, let's get into the suffering. Okay, I really need to get my plasma cutter working, but that's actually pretty accurate for what I was going for. So what we're going to be looking at is, ouch. That's enough to get fully through there. And yes, sirree. Where this falls, I don't remember. Back here somewhere, I think. Yep. Okay. What other plates do we need? So you can see just how long I put this project off for, because there's a date from 12/7/2023 and it is now January 2025. So it's been a long project. All right, so we need a plate to bolt on the end. That one we're going to make out of thinner steel. I've got some 1/8 inch, and we've got this one we've got to make. Let's see what we've got here. All right, for my plan to work, I need to modify the steering arm. So the best way is to take this off. Now, I'm doing this specifically because I can unmodify this by either returning the bar to its previous state, or I have a spare bar in the shed. This is the bar that I took off of the parts tractor that I had a while back. And so it's the same bar. So if I mess this up, I can always go back to manual steering, or if I don't like the final result. So we gotta pull these ball joints, pull the pins here and here, take those nuts off. Let's get this bar off of here. So I'm beginning to wonder, a thought that hadn't occurred to me is, I wonder if this is hollow. Weight-wise, it feels like it might be hollow. If that's the case, it won't completely modify my plans, but I might have to add some reinforcement. I'm not sure. On the other hand, it'll make it easier to machine. Well, you know, since I'm doing this by hand. Alright, so basically we gotta cut a section out of here, and then we have to modify each end to take the pieces that are going to go into this arrangement. So let's do that. Okay, so 11 1/4. So it's going to be roughly there. The idea is to keep this arm the same length it would be when all of this is assembled onto it. So we're saying, and then 13 3/4 to the start of this. Wow, I mean, my measurements came out pretty close. Yeah, I mean, that's where it's going to be. I'll probably cut here first, and if this is hollow inside, I may put a sliding tube inside this so it will keep its rigidity and orientation, so that it won't like have one end flexing, even though this stiff bar will probably keep it from, you know, flopping around too much. If it is hollow, I'll want that reinforcement, I think. Yeah, it's hollow. So we're gonna modify our design a little bit. I think I'm going to find a bar to put in here and basically pin it on one side, drill through here, pin it, and so the one tube will slide inside the other, and then we can make our incision here. Instead of just a slot from the end, this time now it's going to be a total slot. We'll make that, and we'll modify it for our tube, and then we'll drill for our brackets to hold everything together. Okay, let's take a look at what we have so far. Try not to mock my rudimentary fab work too much because, like I said, I'm doing this all by hand. So this is going to be the primary steering bar that is connected to the wheels. Bolted the bracket that's going to hold the linear actuator end pin, and I bolted it all together through the tube and our bracket here. This is going to go between these two bars. I need to shorten it. It's the closest I could find. I think it'll actually, it's not too loose in there. Basically, it'll act as a guide to keep these two in line and be a little better than my initial design. I'm going to shorten this. I think it needs to be about 7 inches, and it is galvanized, so that'll help with keeping it from binding itself together with rust. I made this end plate that'll keep it from popping out of this slot. All this has to do is hold these two together, basically, because this is going to fit in here and slide back and forth. And all this has to do is hold that in and keep it from sliding out. So this is just going to slide back and forth on here with the bracket for the linear actuators attached, while the bracket for activating the linear switches is going to be attached. And then this will join the two. I'm going to bolt it into this one, and it'll slide on this one. I'll mark that and get that set up. There won't be much to hold it in position, which was a failure in my initial design, but I thought these were solid. So it was going to be a little bit harder, and I was relying on these slots to keep it kind of, a little bit in position. But this will actually be a better design and kind of keep it all together as one bar. So more cutting and drilling and tapping, basically. So this is our modified steering bar. We got nice smooth sliding there. I might have to add a grease zerk in here or something going forward, but yeah. I don't know that it's perfectly straight, but it doesn't really have to be straight. I think this plate was bent a little bit. If you look at it, you can kind of see it's got a little bit of a curve to it. I don't really care so much about that because, well, it's not important. It's not a critical geometry. So this is all ready except for the plates for the switches and the plate to activate the switches, which I don't have made yet. So now we need to do the plate to hold the opposing bracket, the other end of the linear actuator. So I decided we were going to use these two screws to hold the bracket. Basically there's going to be a plate sitting against here that is going to be held on by these two, and it's going to stick out, and there's going to be a horizontal that will hold the opposing bracket. Got to get those screws out first of all. Okay, bolts are out. Now we just got to measure that plate to drill it. It's going to go in there. I was taking those bolts out, and I was reaching through this ladder and accidentally banged my elbow on this ladder. And I just recently chipped a bone in my elbow. And I'll tell you what, when my elbow hit the bracket on that ladder, the scream I scrimped. Yeah. Let me just tell you, I can usually handle some pain, but this is really getting the better of me. Anyway, let's see what we can do for that bracket. So I welded the angle of the plate. Would have been easier to use angle iron, but I didn't have any. I'm using what I have. So I just welded this on, and I'm drilling the holes for the bracket for the other end of the linear actuator. I just want to say I have a lot of trouble with drill bits these days. If they even get a little bit hot, even if you're just going tremendously slow and trying to drill through something thick like this, eventually you're going to have heat buildup. Obviously I don't have a coolant set up, you know, on my drill press here, but this drill bit, I was like, this drill bit is just, you know, I'm treating it right and everything, but I always do, and they still end up going dull right away, or the titanium coating wears off right away like they do on these cheap modern drill bits. And I say modern because I looked at this thing and I'm like, I want to know what brand this is, because I want a full set of these. And I'm looking at this, I'm going, okay, 7/32, high-speed steel, West Germany. And I'm like, oh crap, I'm never gonna find a set of these. But if I could, I would buy a full set of these things, because I can't find a set of good drill bits these days to save my life. But this drill bit is tremendously good. These cheap drill bits, and I don't know where I got this. A couple people have given me some tools over the years, so thank you. You ought to be able to drill a normal hole going nice and easy without coolant just by taking it easy, and you can't do it anymore with drill bits. And I've tried running coolant with these things too, and they're just absolute garbage. Don't buy these cheap sets. Buy a West German set is what I'm saying, if you can find one. Oh, and just one more crazy note. You know, I am using Cold War era West tools to fix a Cold War era Eastern tractor, so you know, East and West have finally come together, is what I'm saying. Anyway, once we have these holes drilled for the bracket, for the right size bolts, we can bolt that linear actuator on, and then I think we can test the rudimentary setup of it. So let's finish drilling these holes. I think I got to make them a little bit bigger, and we'll do some testing. So here is what is probably the first edition, because, you know, when something breaks or you revise stuff, yeah, that's what we got. The geometry worked out kind of like I measured. I'm surprised. I must have measured well. All right, so we're going to test it. Temporarily got the box wired up with alligator clips. We're just going to try to run it manually. One of three things is going to happen. It's going to break something, the weakest link. It's not going to work, or it will work. By not work, I mean it just won't have enough power. Let me run these down here at least a little tight so they don't want to pull out. Don't want to ruin the ball joints, the unobtainium ball joints. Let's see what happens. All right. Haha. It is working. It's bogging down. So if I turn this wheel, maybe finally broken. Maybe disconnected from the, oh, there it is. Oh yeah, that sounds fantastic. Yep, I'm hitting the stops there. So if I turn the wheel, you can see how this would activate the yeah. So it is drawing some amperage. It is working though. The question is, let me shut this off. The fuel pump's running. I wonder what'll happen when I use large diameter wires on that. I don't know. I might need a bigger actuator. This will kind of work because I think it'll work while you're driving. So this will work for the time being. It just basically to get the tractor moving again, because I can't steer it at all right now. I have to replace that steering box. I kept the steering box from the parts tractor. It's over there in the weeds, and I can use it to either rebuild the other one or just replace the whole thing. I'm not sure yet what I'm going to do. It's a little different because it has some of the switch gear on the top of the column there, where this is the newer version that doesn't. But I do have to pull out the steering wheel. That's going to be a separate project. Basically what you do is pull this floor plate out, and then you can get to the bolts that hold the steering attachment in, the whole steering column, and then you basically just lift it right up on out of there. Not that difficult, but it is a little time consuming, and these bolts haven't been out for 30 years, so I think this will work. I'm going to take this off again, and I'm going to wire brush down the parts and paint them and keep them from rusting worse, and then I'll put this back together. Alright, I decided to do this a little differently since this tube is hollow, and also I'm going to revise the switch configuration. So I'm thinking, as it slides back and forth, instead of the riding on a circle, why make it that complicated? Just make them hit the end on either limit. So basically, with it pulled all the way this way, make sure it's all the way, we're going to drill the holes for the switch here, basically, and then the same on the other side. Alright, I have these limit switches mounted, and they are cheap, tiny limit switches, but I got a whole bag of them, so they bend a little, but sometimes that happens. That's fine, as long as it activates, and on that end. So we should have everything we need on this now. I'm gonna brush this down, paint it up. I'll take the limit switches off, paint it up, and then we can focus on the electrical side. And in the meantime, I'll try to order a stronger cylinder, but we're gonna make do with the one we have for the moment. So let's make this look a lot nicer. So I kind of painted these up, maybe to keep it from rusting for at least a week. Not trying to make it look nice, just trying to put a little bit of protection on there. That little box, control box for this linear actuator, did not work the way I thought it was, and I'm sure it has nothing to do with the Chinesium instructions. Anywho, I have changed it to use 2 relays. They're just standard 5-pin relays. One controls the negative side of the motor, one controls the positive side of the motor. And since each relay has a pair of normally open, normally closed contacts, basically one set of positive and negative contacts is hooked up together on each relay, like normally open on one and normally closed on the other. That's positive and negative, and then vice versa, so that when one relay is activated, the motor goes one way because positive and negative are one way, and then when the other relay is activated, it goes the other way because negative and positive are switched. So this system is comprised of just 2 limit switches, 2 relays, the motor itself, and then of course power from the battery, which I'm running through a fuse block, which for the cause of simplicity I'm not going to show here. So the limit switches are wired direct to the positive power side, so that when you close one or the other switch, it will supply power feed down the line. And of course you can only activate one switch at a time because of the limit on the bar. You can only move the bar in one direction at a time, obviously. So one limit switch is connected to one relay each for activation purposes, so that when the switch is closed, it will supply power to the relay, and of course the coil side of the relay is always grounded. So as soon as you supply power to the coil side of the relay will activate. The relays themselves are standard 5-pin relays, such that they have a normally closed contact and a normally open contact. So we're supplying power to the normally open contact and ground to the normally closed contact. you could reverse those. You could supply ground to both normally opens and power to both normally closed, and it would work the same way. You would just have to reverse the relays because the motor would spin in a different direction when you activate the respective switch. So when you activate a switch, it will activate one of the relay coils, and it will close the pair of contacts in the relay and open the other set of contacts, and that will supply either a power or ground feed to the motor respectively. And of course, since the other relay has a contact that's not closed, that will now be in the opposite configuration, you will have either the opposite power or ground, and the motor can spin because then it has a positive and negative connection. And of course, when you close the other relay, the situation is reversed, and the motor will spin the other direction because the result is reversed. That's the best I can explain it. I'm not good at explaining these things. There's a lot of back and forth wires. It's not, there's a lot of wires to do it, but it's only 2 relays. I still have this raggedy old steering wheel in here, and it actually has a dead spot in it now in addition to a tight spot. But see, I'm spinning it and nothing is happening. It's very loose. The looseness is part of it, but then it gets too tight at times too. So if you look at, we'll turn the wheel here. Oh, the steering wheel is so tight. This is going to be really hard to test with the steering wheel the way it currently is, because the steering wheel is actually binding. You reach a point and it's making that creaky, cracky, crunchy noise, and it's binding, and you can't physically move it. Sometimes you can force it past that or back it up, but that's kind of why we're finally doing this, because the tractor got here and now I can't steer it out of here basically. So this video is getting kind of long anyway. I'm going to split this up into 2 parts. This is going to be the fabrication part, and then we're going to do a column replacement and do the actual testing and eval of this, and well, any revisions that need done if we reach that point on the second half, because otherwise this is going to turn into a 2-hour video. That's where we're at. So we're going to leave it here, and we're going to do the final testing and column replacement next time, and then maybe we can drive it around, test it a little bit, see how it works, evaluate it, that kind of thing. We're going to do the windshield here in an upcoming video if my piece ever comes. Oh, there's a dog here. Hi, Winston. Hi, buddy. Hi, buddy. We've gotten so fuzzy. Growing out your winter coat. So that's the fabrication side of what we're doing here. I'm sorry I didn't get to testing it, but this video is getting long, and like I explained, it's not going to be right with the column the way it is, because even if it doesn't work, I won't know whether it's the column or the steering, or it's just, let's do this the right way, testing wise. Otherwise we won't get good results. So that's going to be coming up real soon. I'm working on that right now as I shoot this, so that should be out shortly after this video. So I apologize for splitting it up into 2 parts. YouTube wants us to do longer videos, but it seems like my viewers don't want really long videos, because if you're going to spend an hour and a half watching somebody, you might as well watch a movie or something, at least get a real entertainment value out of it. Anyway, I apologize for my videos getting as long as they do, but I want to show things in their completeness, and sometimes that takes a bit of time. So anybody who does take the time to watch it, I greatly appreciate it, as always. And feel free to leave a comment down below, give it a thumbs up, hit that notification bell, subscribe, all that stuff. You know what to do if you're on YouTube. And as always, thanks for watching. This boat that's been in the background is going to be on a future video, because I feel like every YouTuber at some point needs to do a boat, just to learn their own lesson in life about, projects not to do. But we picked this thing up really cheap, and I know literally nothing about it, and I don't think it runs. But at some point we're going to make this run, and we're going to take it out on the water and either sink or swim, basically. And I don't know how to swim, so basically it could get real exciting, So anyway, keep your eyes peeled for that if you're into boats. If not, I apologize, because not a lot of people are into boats. They say it's just a hole in the water into which you throw money, and I agree with that, but I feel like I had to do a boat just because it was real cheap. And well, you know, I like it. So yeah, keep your eyes peeled for that on a future video if that interests you.